Good morning, grade 7 students. Welcome to our virtual class for the third quarter, week 4. Our lesson for today is about sound. I'm Abigail Sarmiento, your science teacher. Would you like to try placing your palm on your throat while saying, "What you doing?" What did your palm feel? Were there vibrations in the throat? Try it again, and this time, say, "Mom, Phineas and Ferb are making a title sequence." Terms to remember. Longitudinal wave. Wave whose motion is parallel to the motion of the particles of the medium. Mechanical wave. Wave that need a medium in order to propagate. Sound is an example of a longitudinal wave. It is also classified as a mechanical wave. Thus, there has to be matter for which sound should travel and propagate. This matter is better known as medium. When we talk or make any sound, our vocal cords vibrate. When there are no vibration felt, no sound is produced. This means that sounds are caused by vibrations. Vibrations of molecules are the to and fro or back and forth movement of molecules. Vibrations are considered as a disturbance that travels through a medium. This vibratory motion causes energy to transfer to our ears and is interpreted by our brain. Sound waves are example of longitudinal waves. They are also known as mechanical waves, since sound waves need medium in order to propagate. You can try this one. Place your ear against one end of a tabletop. Ask a friend to gently tap the other end of the table with a pencil or a ruler. What happens? Then, ask your friend to again gently tap the other end of the table, but this time, make sure that your ear is not touching the table. What happens? In which situation did you encounter louder and more pronounced sound? In which situation did you encounter the sound clearly? Sound is produced by the slight tapping of the table with a pencil or a ruler. This can be heard clearly at the other end of the table. This shows that sound waves can also travel through wood or solid. Sound is more distinct in solids than in air. This also means that sound is heard much louder when it travels in solids than in air. Can sound travel in liquids too? Liquids are better transmitters of sound than gases. If two bodies are struck together underwater, the sound heard by a person who is underwater is louder than when heard in air, but softer than in solids. Particles of solids are more closely packed than particles of liquid and gas. This is why sound produced in solids is much more distinct and louder than when it's propagated or produced in liquids and gas. Between liquids and gases, on the other hand, liquid particles appear more closely spaced than gases. This means that louder sound will be produced in liquids than in gases. Spacing of particles of the medium like solid, liquid, and gas is an important factor on how would it transmitted. Take a look at figure 2. Liquid particles are closer to each other than the particles in the gas. Sound waves are transmitted easier in the liquids. Between liquids and solids, The particles of solids are even closer together than the liquid molecules. Therefore, sound travels even faster in solids than in liquids. Since different media transmit sound differently, sound travels at different speeds in different materials. Since solid is the best transmitter of sound, sound travels fastest in solids and slowest in gases. Sound cannot travel in a vacuum. Remember that sound is a mechanical wave which needs medium in order to propagate. If no matter exists, there will be no sound. In the outer space, sound would not be transmitted. Sound waves possess characteristics common to all types of waves. These are frequency, wavelength, amplitude, speed or velocity, period, and phase. Just like other waves, sound also exhibits wave properties just like reflection, refraction, diffraction, and interference. More than these properties are pitch and loudness of sound. Pitch refers to the highness or lowness of sound. Loudness is how soft or how intense the sound is, as perceived by the ear and interpreted by the brain. And that is it for today, students. Please don't forget to subscribe to our YouTube channel GAITF and log into your account at lcms.gaitf.com, and you can answer the quizzes and activities given by the teacher. Thank you for listening.